G'day and welcome to the first video on the normal distribution. This continues our series on continuous random variables, and this time we'll look at specifically at the normal distribution and some of its applications. So as you can see, it's the normal distribution is in a bell shape, and this is kind of how we calculate study scores and things like that. The way that we describe this function is that we've got this little thing here. So that means that x is the variable and it's normally distributed with the mean of whatever it is and the variance of whatever that is as well. The mean or mu is the maximum value of the PDF. All of the area underneath the curve is equal to 1. Now this one's unique. The mean, the median and the mode all have the same value. So for the normal distribution, the mean, median and mode are all this maximum value here. It's all, it's the midway point. It's also the average of the graph as well. And I guess, it goes without saying, but if you increase the mean, you'll move the PDF to the right. If you decrease the mean, you move the PDF to the left. So for example, here, this normal distribution has a mean of 10. This one has a mean of 20. So it just simply moves the whole bell curve over to the right. I want to talk a little bit about confidence intervals and how the standard deviation kind of works. The standard deviation affects the spread of the distribution. So if the standard deviation increases, if the standard deviation gets bigger, then the curve becomes wider and the maximum will decrease. So a small distribution of a small standard deviation of say 0.5 means that most of the values are around the mean. But as we get to a standard deviation of 1, we get this graph here, so the maximum is reduced a little bit and the data spread out a little bit more. A standard deviation of 2 means the data spread out even more, and a standard deviation of 5 means the data is very spread out like this. Okay, so it just tells us how grouped the data is. Is it all around the mean or is it spread out? So this often has applications in test scores and things like that. If the standard deviation is low, that means that everyone did quite well on the test, or everyone got the same mark on the test basically. If standard deviation is high, it means that the data is really spread out. Now the confidence intervals, we can say that these are approximate values here, but we're saying approximately 68% of the population lies between one standard deviation either side of the mean. So if I go down to this little this diagram here, it's an approximation, 68%, but if I get the mean, which in this case the mean is 0, and I'll get one standard deviation either side, that means that 68% will be in this shaded area in here, approximately obviously. And within 2 standard deviations of the mean, so from here to here, and from there to there, that's going to be 95% of the population that exists between 2 standard deviations. And 3 standard deviation, 99.7%. You need to know these 3 things here. You need to commit these 3 to memory, because in the exam 1, when you don't have a calculator, you'll need to know these things. If you do have a calculator, don't use these at confidence intervals. Actually work it out using the calculator, because it will be a more exact answer. Okay, so we'll make reference to these quite a bit in the next little section. So I want to just go through a couple of questions now to kind of help us understand these confidence intervals and how they might be useful. So here's an example. The germination time for grass seeds in a laboratory is normally distributed with a mean of 40 hours and a standard deviation of 1.5 hours. So find the proportion of grass seeds that germinate between 38.5 hours and 41.5 hours. To answer this question, I would need to draw a diagram to show what I'm actually doing, and I need to put this little X here just to signify that it's the normal distribution. And then I can simply put in the mean, which is 40, and then the standard deviations either side of that, so 38.5 and 41.5. Now, sorry, they're not the standard deviations, they're just the values either side. I can tell that 1.5 bigger than the mean and 1.5 less than the mean, so 1 standard deviation either side of the mean is what I'm actually asked to do here. So the mean plus 1 standard deviation is exactly this one, the mean minus a standard deviation is exactly that one, so I know that approximately 68% of the population exists between 38.5 and 41.5. The next question, I'm asked less than 38.5. So here I just need to use, I guess, some logic. I know that 68% exists in between these 2 lines here, and if the whole thing is 100, that means that 32% exists either side here. So that means, and it's symmetrical, which means this side here has to be 16%. Hopefully you've understood that. So 68%, 32%, 16%. Okay, another way of doing it is to say, well, less than 40 is 50%, and less than 38.5, well, between 38.5 and 40 is going to be half of 68%, half of this one, so half of 34, so therefore that ends up being 0.16 or 16%. Okay, the next one we'll look at is between 37 and 43. Now again, I'm looking at this, I'm not using my calculator, but I recognize that 40 minus 2 times 1.5 is 37, and 40 plus 2 times 1.5 is 43. So this actually has two standard deviations either side of the mean. So that ends up being 0.95 or 95% based on our confidence intervals from before. So the next one, this one's what's the probability of less than 44.5 hours? Well, 44.5 is actually 3 standard deviations away from the mean. And this means that with 3 standard deviations away, I know is 99.7. So that means that 99.7. The other sides here and here would actually only be 0.3. So therefore, this little piece up here is actually just 0.15. So the whole thing would be 100 minus 0.15 to get to 99.85. The other way of doing it is to say less than the mean is going to be 50%, and then greater than the mean but less than 3 standard deviations will be half of 99.7, and so we end up getting that same answer. The next one, between 35.5 and between 40 and to 41.5. So I can tell you that that's actually 3 standard deviations to the left, but only 1 standard deviation to the right. So I would need to get half of the 3 standard deviations, because between 35 and 40 is will get us the 3 standard deviations. That's 99.7 over 2, and then half of 1 standard deviation, because that's where that is. That's 68 divided by 2, and adding those two together ends up getting us 0.8385. Okay, and then finally, I'm asked to find the mean and the standard deviation if of the normal distribution if this question, if this is true. The probability that the x is between 2 and 38, and that's equal to 0.95. The assumption that I've made in this question is that it's symmetrical around the mean, and I might even draw that thing there. So I know that where 2 and 38, all of that area in there is 38%. Sorry, not 38%, 95%. I don't know where 38 came from. That's fine. So this one would be 95%. Okay, and I know that the mean minus 2 standard deviations is equal to 2, and the mean plus 2 standard deviations is equal to 38. So therefore, I can use the simultaneous equations to find out what the mean is and what the standard deviation is. So the mean plus the other mean is 40 is equal to 40 because 2 plus 38. So the mean is actually 20, and then I can sub that back into one of these and I get the standard deviation of 9. So that's how to do most of these questions, or all of these questions actually by hand, using the confidence intervals that I was talking about a little bit before. In the next video I'll show you how to find some of these things on the calculator. So thanks for watching.